The architecture of modern enterprise intelligence relies entirely on the mathematical security of distributed model weights. However, an invisible cryptographic crisis is quietly accelerating across the global cloud infrastructure. As corporate networks distribute high-value AI workloads across multi-tenant environments, standard encryption protocols become prime targets. Traditional perimeter defenses can no longer protect deep learning configurations from advanced adversarial interception. Sovereign entities and malicious actors are actively harvesting encrypted corporate data in transit today. Their objective is clear: hold this intercepted enterprise data until quantum computing architectures can execute retrospective decryption. When quantum decryption capabilities mature, traditional asymmetric cryptographic foundations like RSA and elliptic curve protocols will completely collapse. This imminent systemic failure threatens the core intellectual property of global enterprises. According to the NIST cybersecurity framework, legacy data encryption cannot withstand Shor's algorithm. If your distributed inference engines rely on standard public keys, your entire model topology is profoundly vulnerable. Consider the architecture of a decentralized multi-node inference cluster processing proprietary financial algorithm. Every parameter exchange between nodes represents a massive exposure vector if protected only by legacy TLS encryption wrappers. If an adversary intercepts and clones your model weights, they essentially own your operational competitive advantage. This catastrophic data exposure can happen silently, leaving no immediate trace within network telemetry logs. The vulnerability extends deeply into secure retrieval-augmented generation architectures, known commonly as graph RAG systems. Intercepting vector embeddings allows threat actors to mathematically reconstruct the sensitive underlying corporate knowledge base. Furthermore, automated model training pipelines that pull data across variable geographic regions face severe exposure. Without immediate cryptographic modernization, your long-term research and development investments remain completely unsecured against tomorrow. Data privacy regulations like ISO/IEC 27001 will soon mandate verified protection against quantum-era extraction methodologies. Failing to address these architectural weak points exposes your enterprise to unprecedented regulatory compliance penalties. We must shift our defensive posture from reactive patching to structural, mathematically hardened infrastructure resilience. The absolute protection of enterprise intelligence requires a fundamental revolution in our approach to network data transport. Let us analyze the specific technical parameters of this vulnerability before designing the ultimate solution. Understanding how quantum systems exploit mathematical symmetries reveals the exact path toward building quantum-safe environments. The solution to this systemic vulnerability lies within the domain of advanced mathematical lattice-based cryptography. These frameworks rely on the inherent geometric hardness of high-dimensional vector space problems. Unlike traditional factorization methods, lattice problems remain computationally intractable for both classical and quantum architectures. Integrating these algorithms directly into inference pipelines creates an unbreachable cryptographic defense barrier. Specifically, we look to the newly standardized algorithms known as ML-KEM and ML-DSA. These protocols provide the mathematical foundational substrate required to secure next-generation enterprise multi-agent routing. By deploying ML-KEM, we establish quantum-resistant key encapsulation mechanisms across all active network nodes. This ensures that every individual inference request is wrapped in a highly secure, impenetrable cryptographic tunnel. Simultaneously, ML-DSA introduces lattice-based digital signature algorithms to verify the absolute integrity of weights. This mechanical validation prevents malicious actors from executing unauthorized, high-risk model parameter injections. To implement this successfully, security architects must transition core transport layers to hybrid cryptographic setups. This dual-wrapped approach combines proven classical algorithms with cutting-edge post-quantum mathematical primitives. According to the Crypto-Agile Transition specifications, this hybrid methodology guarantees continuous uptime and performance stability. It allows enterprises to test quantum-resistant capabilities without discarding their existing legacy compliance certifications. Let us visualize how this looks within a production-scale distributed AI inference cluster topology. As request tokens ingress, they are immediately signed using hardware-backed, quantum-safe biometric verification keys. The payload then travels through a software-defined network optimized for low-latency lattice operations. Dedicated cryptographic coprocessors handle the increased computational overhead, maintaining necessary high token throughput speeds. This architectural integration decouples security processing from the underlying deep learning model execution weights. Consequently, your enterprise AI agents operate at peak efficiency while remaining entirely inside hardened network perimeters. Furthermore, securing the model context protocol channels with post-quantum algorithms eliminates stateless communication vulnerabilities. Database connections and external tool calling mechanisms become entirely immune to unauthorized remote credential harvesting. By replacing vulnerable public key exchanges with hard geometric problems, we achieve a verified zero-trust state. This foundational security shift ensures your proprietary models remain protected across any untrusted cloud infrastructure. Transitioning to post-quantum cryptography yields massive strategic advantages that extend far beyond simple data security. First, it completely shields billions of dollars in proprietary enterprise intelligence assets from corporate espionage. Enterprises that secure their intellectual property today establish an unassailable position of operational data sovereignty. This structural resilience builds deep trust with global institutional clients who demand absolute information security. From a macroeconomic perspective, early adoption mitigates the systemic risks associated with sudden tech infrastructure collapses. Maintaining continuous AI availability protects core revenue generation channels from devastating quantum-driven market disruptions. Furthermore, this transition profoundly impacts the corporate labor landscape and organizational training requirements. Security engineering staff must rapidly upskill, moving away from outdated, legacy asymmetric mathematics certifications. Organizations must invest heavily in training personnel to manage complex lattice-based key life cycles effectively. This workforce transformation elevates security teams from traditional network administrators to elite quantum risk architects. According to global technology research, the demand for specialized quantum-safe professionals will increase exponentially. Upgrading your internal workforce capabilities today prevents critical talent bottlenecks during future mandatory migration phases. Let us evaluate the specific operational impact on engineering workflows when processing high-volume vector transactions. While lattice-based public keys are mathematically larger, modern optimized compilers drastically reduce computational execution overhead. By leveraging hardware-accelerated instructions, token latency increases are kept to a virtually imperceptible minimum. This ensures that user experience metrics remain completely unaffected during complex, multi-agent, real-time interactions. Additionally, data loss risk models show a dramatic reduction in potential liabilities post-migration. Preventing retrospective decryption attacks removes the ticking time bomb scenario currently threatening long-term enterprise cloud data archives. This proactive security posture directly translates into reduced insurance premiums and enhanced corporate valuation metrics. Board-level risk oversight committees can confidently verify that the organization's primary digital assets are completely future-proofed. The intersection of post-quantum readiness and artificial intelligence represents the gold standard of modern digital transformation. It proves that technological advancement does not require sacrificing fundamental data protection principles or corporate operational control. As we navigate this paradigm shift, the strategic benefits become increasingly clear to forward-thinking executives. Let us now outline the definitive implementation roadmap required to achieve this hardened security state. Executing a successful post-quantum cryptographic migration requires a disciplined, multi-phase operational engineering roadmap. Phase 1 demands a comprehensive architectural audit of all existing data-in-transit pipelines across your enterprise. Security teams must systematically map every single endpoint, microservice connection, and external database bridge. Identifying where legacy encryption algorithms are currently deployed is the critical first prerequisite for remediation. Next, prioritize wrapping your highest value assets, specifically your distributed model weights and proprietary vector databases. Establish secure quantum-resistant tunnels using hybrid ML-KEM protocols to immediately neutralize immediate interception threats. During Phase 2, deploy updated software container images containing pre-compiled post-quantum cryptographic provider libraries. Utilize container orchestration platforms like Kubernetes to manage the automated rollout across your multi-tenant cloud infrastructure. It is vital to monitor system performance metrics closely during this initial deployment phase. Track token throughput, memory allocation limits, and network replication delays to ensure operational stability criteria are met. Simultaneously, integrate automated key management solutions designed to handle the unique requirements of lattice-based structures. Dynamic key rotation protocols must be systematically enforced across all active distributed inference nodes. Phase 3 focuses on the complete modernization of your identity federation and access management frameworks. Transition all authentication tokens to hardware-backed, quantum-safe standards to eliminate credential cloning vulnerabilities entirely. Collaborate closely with your external cloud service providers to verify their underlying physical hardware readiness. Total data sovereignty requires that every layer of the technology stack supports native post-quantum execution. Establish continuous automated red teaming campaigns to actively test the resilience of your newly deployed defenses. These simulations must specifically utilize advanced mathematical models to locate any residual architectural weaknesses. As the migration matures, update your formal governance documentation to reflect the new cryptographic controls. Aligning your internal operational procedures with updated global standards ensures long-term regulatory compliance success. Regularly reevaluate your system error budgets and performance overhead profiles to optimize resource utilization. Fine-tuning the cryptographic parameters guarantees that top-tier security never comes at the expense of system agility. With the architectural roadmap fully deployed, your enterprise AI framework stands completely insulated from next-generation threats. Let us synthesize our conclusions and look toward the future of secure global intelligence networks. The dawn of the quantum computing era is not a distant theoretical problem for future executives. It is an active engineering challenge requiring immediate structural changes to our current digital infrastructure designs. Protecting distributed artificial intelligence weights is the definitive security battlefield of the modern digital enterprise. Securing these core assets guarantees your organization retains its fundamental intellectual and economic advantages. Lattice-based cryptography provides the verified mathematical framework needed to achieve true, long-term information sovereignty. Implementing these protocols transforms your security architecture from a defensive bottleneck into a strategic business enabler. We have demonstrated that the increased computational requirements of quantum-safe algorithms are entirely manageable. Through hardware acceleration and optimized software engineering, enterprise systems can maintain peak performance metrics. The workforce upskilling required for this transition ultimately strengthens your organizational capability matrix. Transforming your technology team into quantum-ready professionals ensures your business remains a leader in technological innovation. Furthermore, proactive migration isolates your enterprise from the chaotic regulatory scrambles that will inevitably occur. When global compliance mandates officially shift, your infrastructure will already be fully validated and operational. Do not wait for a public cryptographic breakthrough to begin upgrading your distributed network tunnels. The threat vectors are actively gathering data today, making immediate implementation the only logical path forward. Commit the necessary capital and engineering resources to execute this migration plan systematically and thoroughly. Structural security is an ongoing investment that underpins the entire future of automated corporate intelligence. By anchoring your multi-agent configurations inside post-quantum perimeters, you secure the future of automation. Your AI agents can collaborate safely across global boundaries, completely immune to external mathematical exploitation. This is the architectural standard demanded by the modern global economy and sovereign data laws. Elevating your cryptographic standards preserves data integrity, corporate trust, and systemic long-term operational stability. The tools are available, the mathematical frameworks are standardized, and the deployment path is clear. The responsibility now falls on technology leadership to execute this critical quantum-resistant transformation. Zero hype, pure architecture. Secure your models, protect your data pipelines, and fortify your enterprise against the next generation of exploits. The future belongs to those who build impenetrable algorithmic fortresses today.